Our lecture for today is productivity. In this lecture, we have several overviews. First one is brief description of productivity. Second one, types of productivity. What kind of types we have in productivity. And next one is labor productivity. We will learn how to measure labor productivity level in businesses and enterprises. The next one is productivity improvement in businesses. The last one we'll see several examples and we will learn how to calculate productivity level in businesses and enterprises. Okay, let's get started. What is productivity? In economics, productivity refers to how much output can be produced with a given set of inputs. In the other word, productivity measures output per unit of input such as labor, capital, or any other resource. We have a formula here. Productivity refers is P equals output obtained over input spent. The brief definition of productivity, you may see the process here. Productivity is a relationship between outputs generated from a system and the inputs that are used to create those outputs. Mathematically, P equals output over input. As you see, we have a process here and we have outputs and inputs. Inputs, these are labor and capital, and outputs, finished goods and services that companies and businesses can sell on the market. They may be finished goods and services. It's all outputs. Productivity, in the one word, is a relationship between output and inputs. To be more precisely, we will see in next slides. Okay, we have a system concept here. Inputs, as you see, land, people, capital, facilities, equipment, tools, energy, materials, and information. And outputs are goods and services that we can sell on the market. We can deliver to the customers. And the relationship between inputs and outputs is productivity here. It means inputs transformed to outputs and how much input we spend, what level of outputs. And the relationship outputs and input is productivity. If a company has a higher productivity, it spends lower inputs, it means lower resources, and can get higher outputs, more goods and services. And we'll see what is input and what is output. Let's begin with inputs. In one word, inputs are resources. Resources spent for manufacturing or producing finished goods and services. Labor and capital are the two main types of inputs. Outputs are quantity of goods and services produced in a given time period. You have to notice here is it is in given time period. Output from an industry or sector is usually measured by gross value added GVA. What kind of productivity there are? Types of productivity. Productivity consists of two main types. First one is a multifactor. The second one is a partial factor. Partial factor consists of several parts. First one is labor productivity, capital productivity, material productivity, and machine productivity. So what is a partial factor productivity? Partial factor productivity is considered as a ratio of output to partial or single input which is consumed in the production. Each unit's productivity is measured by partial productivity is the significance of each input factor is determined in the production of output. Partial input is categorized as capital, labor, material, machinery, and so on. Partial factor productivity measurement is as mentioned below. We have formula partial factor productivity or PP equals output our input, partial input. So let's begin with multi-factor productivity. What is multi-factor productivity? As we discussed above, that partial factor productivity includes one single input, for example, labor or capital or material or machine, wherein in multi-factor productivity includes the relation of the total output with the total input such as labor, capital, material, etc. In other words, multi-factor productivity is defined as the ratio among total output and total input used to produce the total output units. This is a formula for calculating multi-factor productivity. Total productivity equals total input our total output our total input. Input consists of labor plus capital plus material plus any other inputs. These are all resources that we spend to get total output here. Okay, let's learn partial factor productivity by one. Let first begin with labor productivity. In simple terms, per person output ratio or actual financial yield based on per hour of work is termed as a labor productivity. It is used to measure a worker's efficiency in producing a higher value product. In other words, one can measure labor productivity by determining the total number of products produced, total output per hour. The formula labor productivity equals value of goods and services produces total output. These are total output, and input man hour. This is total labor input. And by using this formula, we can calculate the actual productivity level of labor. Capital productivity is the relation between total output in terms of goods or services and the input in terms of physical capital. Different assets of an organization, such as machines, building, land, tools, manpower, etc., are essential in production setup. And to meet this, capital is required. So capital productivity can be calculated through the below formula. Capital productivity equals total output over total input. Material productivity is the next topic we should learn. This consists of the ratio between total output and total material input. This material under input includes both direct and indirect raw material, which is used to produce the final product. The technique of material productivity is utilized in measuring the productivity in form of material cost. In other words, material productivity refers to the output produced in numbers of or amount based on the per unit cost of material used as input. It means used as resource. Material productivity formula here, material productivity equals total output over material input. It's in numbers. Material productivity equals total units produced over total material cost. This is calculated by amount. First formula for numbers. Second formula for amount. Machine productivity. As we see earlier, machines are major factor of manufacturing and production. That's why we have to use the productive of machine. How productive machine we have. Machine productivity, this is the relation between total output and total machine hours that are used. Using this technique, the productivity of machines in manufacturing units can be measured. In other words, machine productivity measures the proficiency of a machine in transforming raw material into finished goods or services. So you can see here raw materials transformed into finished goods by machines. The productivity is a proficiency of machine in transforming raw material into finished goods or services. We have formula here: machine productivity equals total output, total machine input. Okay, the next one we have to talk about is labor productivity versus personal productivity. It may be said that labor and personal saying is the same, but in economics, in business, there is a difference between labor and personal. Labor productivity, in simple terms, per person output ratio or actual financial yield based on per hour of work is termed as a labor productivity. It's used to measure a worker's efficiency in producing a higher value product. So on the other hand, personal productivity is the term personal is used for employees who do not work directly on machines. Who do not work directly on machines. It means some experts. These are experts and the support in operation by performing other tasks related to operations and production. The meaning a simple difference between labor productivity and personal productivity. Labor productivity is the efficiency of workers, and personal productivity is the efficiency of experts, workers that do not work directly on machines or on machines. Okay, what factors affect workplace productivity? It means labor productivity. What factors can affect labor productivity? We have several factors that affect to labor productivity. The first one, of course, compensation, salary, wage. The next one is work environment, training, career development opportunities, wellness and diversity, increased responsibility, management quality. What benefits of productivity growth? The benefits of productivity growth. There are several benefits of productivity growth. The first one is the higher wages for workers, lower prices for customers, and higher profits for business, for enterprises, and stronger economic growth for the whole economy. It means higher. Let's begin with higher wages. Productivity growth enables firms to increase wages for workers. Unit labor cost (ULCs), which measures the labor cost associated with the producing 1 unit of output, decrease as the labor productivity increases, meaning that firms can offset the effect of wage increase on profits with productivity improvements. Businesses can pass on productivity improvements to consumers through lower prices without reducing profits or wages. This also makes businesses more competitive in global markets. We have to emphasize that the lower price can also make businesses more competitive in global market, not in the local market. On the other hand, in global markets. High profits. In response to improvement in productivity, businesses can increase their profits as at no cost leads to produce a given level of output. These profits can be distributed to the business owners or shareholders or reinvested into the firm. Stronger economic growth. Labor and capital inputs tend to be subject to diminishing marginal returns. In other words, holding other inputs constant, the addition of some more unit of labor or capital will lead to smaller and smaller addition to output. Okay, let's say in graph the summary of benefits of productive growth. If businesses and enterprises can increase the productivity level, can achieve productivity growth, the wages increase for workers, prices decrease for customers, businesses may get more profits, and the whole economy can achieve economic growth. There are these are four benefits of productivity growth. Real world let's see a real world example of productivity growth. Uh, as you know, the Toyota auto manufacturing company is one of the best and one of the most productive and largest auto manufacturing company in the world. Auto manufacturing giant Toyota offers a prime example of high-end productivity in real life. The company has very humble beginnings but has grown to become one of the largest and most productive car manufacturers in the world. Its Toyota Production System (TPS) is one of the main reasons for that. TPS includes a few of the following principles for achieving the most productive car manufacturer in the world. So let's begin. First principle: an environment of constant learning and improvement. The next one is standardizing systems for consistent quality, and the third one is the elimination of waste. The elimination of waste, not just reduction of waste, elimination of waste. By enacting TPS practice into manufacturing every day, Toyota ensures the company is continually improving, operating at high standard, and resources are not being lost. In summary, we have several summaries here from this lecture. The first one is the productivity in economics measures output per unit of input. When productivity fails to grow significantly, it limits potential gains in wages, corporate profits, and living standards. The calculation for productivity is output by a company divided by the units used to generate that output. Productivity in the workplace refers simply to how much work is done over a specific period of time. How much work is done over a specific period of time. Okay, in this slide we will see several examples and we will learn how to calculate productivity level of the companies or businesses. Solving productivity related problems. Examples. Example number one. Suppose the worker works in chocolate factory. The manager wants to measure the labor productivity of his workforce in order to make operational improvement at the factory. The manager estimates that during a 40-hour work week, the worker produces 2,000 chocolate bars. So the manager calculates the worker's labor productivity as follows. So output here we have 2,000 chocolate bars. Input here is time, 40 hours worked. Output our time, output our input equals uh, 50 chocolate bars per hour. The labor productivity of this worker is 50 chocolate bars per hour. Next one. While while this it means while this allows worker performance to compare to other employees in the chocolate bar branch, the manager cannot compare the worker to employees in the chocolate biscuit division because chocolate biscuit division workers produce biscuits, not chocolates. The manager cannot compare the worker to employees in the chocolate biscuit division because there are two types of product are producing. To, uh, to allow for comparison, the manager estimates the gross value added of the worker producing 2,000 chocolate bars is $4,000. The manager then calculates the worker's labor productivity as output here $4,000 in amount, $4,000 estimated gross value. Input time input here 40 hours, the same as the following slide. output hour time output hour input equals 4,000 over 40 equals $100 gross value per hour. The labor productivity of this worker $100 gross value add per hour. It allows the manager to compare the chocolate bar worker to compare with the worker who is working in biscuit division. It's our second example. So the last slide we have a problem here, single factor and multi-factor productivity problems. Let's imagine MG Juice is a food and beverage company. MG makes 1,000 bottles of juice per day. The following resources: labor 40 hours per day, $12.50 per hour. Raw material 2,000 kilo per day or $1 per kilo. Energy: the company spends $500 per day energy. Capital costs and $1,000 per day. We have to calculate what is the labor productivity per labor hour for these products. It means 1,000 bottles of products. And what's the multi-factor productivity for these products? The second one we have to calculate. And third one is what percent change in multi-factor productivity if the company can reduce energy costs by $100 per day without cutting production or changing any other inputs. In next slide, we will learn how to calculate these three productivity levels, and we will learn how to calculate all of them. So let's learn how to calculate productivity. So we have to calculate productivity level. So A. So before beginning the calculating labor productivity, let's see what kind of numbers we have. We have outputs 1,000 bottles of juice, and we have inputs. So first one is labor 40 hours, $12.50 per hour. So we have raw material $2,000 per day, and energy $500 per day. Capital cost $1,000. So we have to calculate labor productivity. So what's the labor productivity? Labor productivity formula equals output hour input labor. So we have 1,000 bottles of juice output and 40 hours labor input equals 25 bottles of juice per hour. 25 bottles of juice per hour. So next one, B. We have to calculate multi-factor productivity. So the formula for multi-factor productivity is total output over total input. So total output for our our problem is 1000 bottles of juice, and we have total inputs 40 hours multiply 1250 plus 500 energy plus raw material 2000 plus capital cost 1000. So 1000 over 4000. Let's calculate these. 0.25 bottles of juice per dollar. So multifactor productivity equals 0.25 bottles of juice per dollar. 0.25 bottles of juice per hour. So the last one we have to calculate percent change. We have to calculate percentage if company can reduce energy cost from $500 to $400. Okay, if company can reduce energy cost by $500 to $400 per day without cutting production or changing any other inputs. So we have multifactor productivity 1000 bottles over 4000 total input. So as you can see, this from 500 to 400, it is a $100 reduce. So we have to minus from 4000 minus 100. So we have $3,900. If we calculate this, we can achieve such kind of number, 0.2564. If a company can reduce from 500 energy cost to 400 and can reduce input by $100, the multifactor productivity for after this 0.2564. So we have to calculate percent change. For calculating percent change, we have to calculate percent change. So for calculating this, we have to multifactor productivity after change over multifactor productivity before change. So let's put in actual numbers here. Multifactor productivity after change is 0.2564 hour. As you can see this, we have multifactor productivity before change 0.25. So we have to divide by 0.25 and we can achieve 1 point such kind of number. For calculating percent change, we have to minus 1 and we have to multiply 100 to achieve percentage. So if we 1.0256 minus 1 multiply 100, we can achieve 2 point percentage change. So the meaning of this number is if we can reduce 100 inputs, if we can reduce $100 input, and we can increase our productivity to 2.56%. So that's for all our problem. So let's summarize this. A, 25 bottles per hour. B, 0.25 dollars per 0.25 bottles per dollar. C1 is multifactor productivity change is 2.25%. So thank you for your attention. Our lecture is over for today. Thank you.